So before we get started on our toolpaths, let's take a quick look at some of the things on here. We have these slots. They go all the way around the part. There's 4 of them, every 90 degrees. We've got a hole that goes all the way through, and we can say Analyze Dynamic and pick that inside bore, and it'll tell us here that the radius is 0.75. So this is an 1.5-inch diameter hole going through the center of the part. So we'll probably be able to use just an 1.5-inch diameter drill and go right through the center. And that'll give us room to come in here to bore out the rest of this with a boring bar. Let's rotate around to the other side. This will be important for later. I can also do an Analyze Dynamic, and I can pick this little fillet in here. And this will tell us that that radius is 0.062, or a 1/16 radius. So we're going to need to know that later on when we machine that side of the part. But for now, we need to do some basic turning. We need to face off the front, and we need to turn down the outside diameter. So let's start with the facing operation. We're going to go to Toolpaths and Face. I'm going to go with the default name for the part. Say OK. I'm going to use my standard rough turning tool and add a comment. And I'm just going to say face off the part. For my face parameters, there's really nothing to put here. We're going to use the stock and face to 0. We'll say OK. There it faced off the front of the part. Next, we want to turn down the outside diameter. And we do have a solid model here. And you'll notice that that slot runs right through the center line of the part, where we would normally get our profile from. So I want to show you a problem that you can encounter with parts like this. If I go to Toolpaths, Rough, now since it's a solid part, I want to do a solid selection. And when I do that, it gives me a cutaway profile through that center line. And you can see there's a notch here. Well, that notch is the slot. So if I was to use this as my turn profile, I would be turning this diameter down way too small. And also, with that hex on the front, it depends whether I'm getting the high point of the hex or whether I'm getting one of the low points on the flat side. Could make a big difference in what I actually get for turning down this profile. Let me close that. So what I need to do is to get some kind of a profile from this that represents the outside of the part at its widest point. And there's a tool for doing that. We can go to Create and then select Turn Profile. It says select the solid. We're going to pick our part and end the selection. And we've got a couple choices here. One is to just do a slice. Now a slice is what we just saw. It did a slice through the slot and gave us the wrong profile. We needed to figure out what this profile is going to look like when the part is spinning. Because when the part's spinning, you won't see the slot. We'll get a full outer profile. So make sure this is set to spin. Next we have Tessellation Tolerance. This is basically how it's going to put the geometry together, within what tolerance. For this, since it's not a very complex part, I'm actually going to set this to 1/10,000th. I have had a problem sometimes with a 1/1000th tolerance where the geometry that it created didn't fit together as nicely as I would have liked. And I've had some incomplete chains. But by setting the tolerance to 1/10,000th of an inch, I get a much tighter fitting profile. And then we can tell it which profile do we want. Do I want the upper profile or do I want the lower profile? Well, we're machining on the upper side of the part, not on the lower side of the part. So it's upper or lower from center line. We want the upper. You can also tell it to do a full profile, so it'll do a profile that goes all the way around the part. We don't need that either. So with these selections, I'm going to say OK, and it created our profile. Can't see it very well. I can turn off my solids by clicking on the wireframe ball next to the blue ball, and we'll see that there's some green geometry there. We zoom up a little bit, you can see how that follows the profile. So that'll be our boundary for the toolpaths.